Hey everyone, this is Ashwin here. In this video we are going to solve the problem Red John is back. Red John has committed another murder. This time he doesn't leave a red smiley behind. Instead he leaves a puzzle for Patrick Jane to solve. He also texts Teresa Lisbon that if Patrick is successful he will turn himself in. The puzzle begins as follows. I think this Red John character is from Mentalist. I don't know guys if you guys watched the series, but yeah, it was good. Now let's read the problem more deeply. There is a wall of size 4 cross n in the victim's house. The victim has an infinite supply of bricks of size 4 cross 1 and 1 cross 4 in her house. Like you could place the wall in brick in either sides. That is either vertical or horizontal. Now there is a hidden safe which can be opened by a particular configuration of bricks. First we must calculate the total number of ways in which the bricks can be arranged so that the entire wall is covered. Okay, and then the following diagram shows how bricks might be arranged to cover where 1 n is equal to like 4. So this is when the wall is arranged like only 1, and this is for 2, 3. So we have like only one combination for 1, 2, 3, and for 4 I guess we have to come out of this full screen view, and for 4 we can arrange like 2 possible ways. So we can arrange in the vertical or we can arrange in the horizontal. So there is one more step to the puzzle called the number of possible arrangements m. So after we find the number of possible arrangements, Patrick must calculate the number of prime numbers p in the inclusive range 0 to m. So after this we have to calculate the number of primes in it. We have to calculate the number of primes using sieve algorithm, which will have the time complexity of order of n. And as an example here n is 3. For the diagram above we determine there is only one configuration that will cover the wall properly. So 1 is not a prime number, so the p is 0. And another example we have a configuration of 5. So the bricks can be oriented in 3 total configuration that covers the wall. So these are the configurations. The two primes 2 and 3 are less than or equal to 3. So the total number of primes is 2. So that is the result. We will be returning that. So I think this problem is quite straightforward. So we will solve like separate subproblems. First we'll calculate the possible arrangements, and after that we will get the result, and we will pass the result to the sieve of eratosthenes algorithm, which is used to calculating the number of primes. And let's see the constraint. Here we have test case around like 20 and the number is around 40, which is pretty less. I think we could easily solve this problem without exceeding the time limit. And this is some test case like 2, and for 1 it is 0, and for 7 the number of primes is like 3. And here the total number of ways we can arrange this configuration is like 5, and there are 3 primes that are less than or equal to 5. And let's solve the problem now. Okay, first we will calculate the number of ways of possible arrangements. So number of ways of n. First we will solve this. Def number of ways of n. If n less than or equal to 3, as I already mentioned, if the number of bricks is less than or equal to 3 means we have only one configuration, so we will return 1. Now if n equals 4, if it is 4 means we have like 2 possible combination, like we can arrange it in vertical order or horizontal order. So return 2. So these are the base cases. So if it is more than that means we will return number of ways of n minus 1 plus number of ways of n minus 4. So when we negate minus 1, so let's say we have like 5 means if we negate minus 1, the remaining combination we have is 4. So that is like one sub problem. Other than that, if we want to calculate the sub problem for this remaining individual, let's say if we have like 6 or 5 means, we have to solve this sub problem which has like 3 more bricks. So that's why we are having number of ways n minus 4. So that will remove this bricks. So this one will calculate the number of possible combination for this, and this one will calculate the number of possible combination for the additional bricks except this. So using this function we can calculate the number of ways, and after that total primes equals, I'll just call it as like P equals sieve primes. I'll just call it as it is, and I will pass the n ways here, and finally I will return the result. So P will consist of the total number of primes that are less than or equal to n number of ways. Now we will define the algorithm here, sieve primes of n. I hope you guys use this algorithm for calculating the primes in the optimal way. So we are going to do the same. So I will say primes equals, initially I am just considering all the index as a primes, and I will go up to n plus 1, and for I in range of 2 we will just start from 2 because that's how we are going to iterate. So int of math dot square root of n plus 1 plus 1, and after this if primes of I, that means if the index is already a prime, we will iterate through the remaining index and update those numbers or not prime. So initially it was like 2, so we will iterate from this. So for j in range of, so I will be in 2, so I into I, so I'm just starting from the next possible index, that is I multiplies I, and I will go up to n plus 1 with the increment of I. So it will be just starting from 4, and it will keep on going like 4, 6, 8, 10, like that it will keep on going, and we will be updating the primes of j equals 0, meaning that those numbers are not prime. So it will again go for 3, so 3 will be like prime, and it will do the same operation for 3, and if we go for 4 means it won't be a prime and it will go to the next index. So using that we will just calculate all the primes. So now this array will contains 1 for all the primes except 0 and 1, it is not a prime numbers, so we have to negate by 2 from the total sum. So return sum of primes minus 2. I will also have a comment, negate by 2 to avoid 0 and 1 as primes. So this will give you the total number of primes that are less than or equal to n. Now that's pretty much it, guys. So maybe we could trace for one example, let's say 7. So for 7, if you consider this, I guess I have to like go for a tree. Before that I'll just run the code once just to check I wrote the code correctly. Yeah, it passed the sample test case. Now let's trace through the example. So initially we have 7, I'm calling the number of ways. So number of ways n minus 1 and n minus 4. So I will say n minus 1 is 6 plus n minus I'll also pass the function so it will be easy for you guys to observe. And we have n minus 4, that will be 3. We know the result for number of ways for 3, that will be like 1, right? So that will be like one combination. And after this we have to go to this 6, and again we will be having 5 plus 2, and again if we go again, this will be 4, and if it is 4 means we will be returning 2 for this. So we have 2 here, replace the 2 here, 2, and this will be 1, and the total will be 3, and we have 3, and this will be 1, and the total will be, okay, did I miss anything? Okay, I missed for 5 we have to add another number of ways. So number of ways of 1, that will be 1. So total will be 3, and for the number of ways of 5, this will be 3, and this total will be like 4, and 4, and number of ways of 3 is again 1, and if you add it together, the total number of ways is 5. So we have found the total, and I guess you guys would have already know the sieve of primes. I'll just do it again. So I will have it as like 6 ones here, 1. Okay, we have 6 ones, and we will be starting from 2. So if we start from 2, this will be changing to 0, and if you go from 3, there won't be any number. 4, it's already 0, we won't be touching, and 5. So again, if you calculate the sum of primes, the total will be like 5, and we have to avoid these two. So if we consider this and this as 0, so the total will be 3. You could either change the array at the start, or you can just negate it by 2. So both are same. So the total values are 3, which will be the result. Return 3. I hope you guys understand the logic. If you have any other logic apart from this, please leave a comment below. Apart from that, if you like this video, hit the like button, and don't forget to subscribe the channel for future videos like this. Stay tuned for the next video.